Alright, good day everyone. It's awesome to have you back. Last week we introduced you on the various topic treating. As per today, I'll be taking matrices. Matrix and determinants. Matrices and determinants. And along the topics, how we are going to be doing it, I want everyone to pay attention to every details, because everything that we are going to say, it has a hereafter, and you need to put your mind, don't skip any part of this video. So then another thing that I want to tell you that irrespective of who is taking the course, let's try to, because no one is an island of knowledge. So when it comes to knowledge, irrespective of the person passing the information, let's try to remain calm. And I think this is a way we can learn more and more for our own betterment. So after today, I'm taking matrices. I know this is a topic that we are used to, then we are familiar with, but there are some basic concepts we need to understand when treating a matrix. So the question is, what is what matrix? Matrix is the rectangular arrangement of elements of numbers in a row or column, which is enclosed by a bracket or parentheses. So the arrangement of numbers or alphabet can be an alphabet. If I say A equals to, so this bracket I'm having, we call it parentheses. Let's say A, B, C, D. Now the arrangement of numbers or elements, okay, in form of rows and column, that's what we call what? Matrices. Then the matrix has been very useful in the mathematical aspect of science, social science, administration. Like in the aspect of social science and administration, topics like regression, topics like linear programming, and some other complex topics under Jacobian, X theorem, we apply matrix. So it's very important for us to pay much attention, because this is just a foundation of what we need about, all we need to know about matrix. So as I was saying, I said that matrix is the rectangular arrangement of elements, okay, in form of rows and columns, which the matrix or element is enclosed by what we call a bracket or a parenthesis. So the arrangement now. So the horizontal arrangement like this now. The horizontal arrangement of numbers or elements is what we call what? Rows. While the vertical arrangement of what? Of numbers is what we call what? Column. Then one thing about matrix, it has to do with your matrix A, I times J. The I represents row and the J represents column. As I said the horizontal arrangement of numbers or element is what we call rows, while the vertical arrangement of numbers or element is what we call column. So we'll be looking at various types of matrices. I think that's where we start from. So types of matrix. Type of matrix. Number one, we have types of matrix between. So these are the three types of matrix that we have. In each of the three, we have subdivision. So we have subdivision. So we need to explain each of these types now. So when we say rectangular matrix, this is a form of matrix in which the rows and column of the matrix or the elements are not the same. Then in a rectangular matrix, we can have what we call leading diagonal or principal diagonal. Take for instance, let's say matrix A is A, B, C, D, E, F. Look at this now. With the shape, if we try to draw, it forms like a rectangle. So the reason why we said, if you look at your rows, I told you rows is the horizontal arrangement of numbers or elements. We have 1, 2. We have 2 rows times how many columns? 1, 2, 3. Definitely the rows and columns there, they are not the same. So in a rectangular matrix, the rows and columns are not the same. So right there you have 2 by 3 matrix here, rows and what and column. So what I'm saying there is also that in a rectangular matrix we don't have a leading diagonal, in the sense that, say for instance, let's explain square matrix now. When we say square matrix, is an order of arrangement whereby the number of rows is the same thing as the number of columns. Take for instance, let's say matrix B is A, B, C, D. Now look at this now. The number of rows 1, 2 is the same thing as what? Number of what? Columns 2. So definitely this is square matrix. This is what? This is square matrix. Then in a square matrix, let me repeat what to explain what I mean by leading diagonal. In a square matrix, we have what we call leading diagonal. This side is what we regard as what? Leading diagonal. In a square matrix, we have leading diagonal. But if you look at your rectangular matrix, we can't, let me repeat well, the example A, B, C, D, E, F. Now, we can't, the way we did this, we can't do it here and say, so this is what we call what? Leading diagonal. So in a square matrix, the number of rows and the number of columns, we have what? They are the same. But in a rectangular matrix, the number of rows, what we have in your rows, is not the same thing as what we have in your column. Then in a rectangular matrix, we don't have what? Leading diagonal. But in the square matrix, we have what we call what? Leading diagonal. Then the next one is a row matrix. Row matrix, I think I've explained that. I said row matrix is the horizontal arrangement of elements of numbers. So it's the horizontal arrangement. Take for instance, like say A equals to, let's say A, B, C. Now, if you are being asked how many rows do we have, the horizontal arrangement of elements. So these were called your rows. But your column now is the vertical arrangement. Now, like this matrix now, this 1 times. Okay, how do you bring in your column matrix? The vertical. This side 1, 2, and what? And 3. Then this 1 by 3 matrix. 1 by 3 matrix. So your row matrix is the horizontal arrangement of element, while the column matrix is the vertical arrangement of numbers or elements. Then the next one is soluting matrix, on one single soluting matrix. In this matrix, we can substantially say whether this is your rows and this is your column, but in that matrix we have one by one matrix, like your row is the same thing as your column. If for instance matrix A equals to only element A. Now we can call this horizontal, we can also do it like this, vertical. So therefore this one times one matrix. One thing that if you want to measure in the dimension of the matrix, your row comes first, followed by what? Your column. Then I said your rows is the horizontal arrangement of numbers. So while your column is the vertical arrangement. So I think that's relationship between rows and what? And column under that. Then the next one, under this type we have non or zero matrix. 2, we have unit matrix or identity matrix. 3, we have killer matrix. 4, we have diagonal matrix. And 5, we have diagonal matrix. So using structure of matrix, we have non-matrix, unit matrix, scalar matrix, and then we have diagonal matrix and triangular matrix. There is a reason why we need to explain all this, because in our service we need to understand some terms and concepts. Okay, what kind of matrix am I dealing with now? So non-matrix. Non-matrix is a form of matrix in which all the elements in the matrix are what? Are zero. All the elements in the matrix are what? Are zero. If for instance matrix A equals to 0, 0, 0, 0, 0. So this is a what? A non-matrix. But the dimension of the matrix, column and rows, that's 2 multiplied the column 2 by 3. So this form of matrix, since all the elements are zero, so we call it what? Non-matrix or what? Zero matrix. Then number 2, we have unit. As its name sounds, or what? Identity. As the name sounds, unit or what? Identity matrix. The word unit means 1. So what we are trying to say is that this is a form of square matrix having 1 in the leading diagonal. I told you where you can have a leading diagonal matrix is under a square matrix, which we consider the other time under relationship between rows and column. So unit matrix or what? Identity matrix is a form of matrix in which the elements in the principal diagonal or leading diagonal, or they can call it main diagonal, are what? Are 1. So it's a square matrix. If you, let's say element A, we have something like 1, 0, 0, 1. So the leading diagonal is this. All the elements that are there is what? Is 1. 2 by 2 matrix. If for instance, okay, let's say 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, in the leading diagonal, we have what? 1 or 2. So that's what? An identity matrix. An identity matrix. Then the other one, we have what? Scalar matrix. Scalar matrix. Please, as you are watching, try to like and subscribe. Try to share with your colleagues, that you know that it will surely benefit them. So I think this is the best way you can show love to us in return. So then the next one we have scalar matrix. Scalar matrix. Scalar matrix is also form of, it looks like an identity matrix, but what we have in the leading diagonal is not 1. Hope you get that. What we have in the leading diagonal is not 1, but it can be any other value, but the value that must be there must be the same or true. Must be the same or true. So it's a square matrix having elements, equal elements in the leading diagonal, apart from what? Apart from 1. So if for instance A equals to, I can say 2, 0, 0, 2. Now I'm not using 1 here. So in the leading diagonal I'm having 2 or true. So this is 2 by 2 matrix. So in the leading diagonal we have 2 or true. So we call it scalar matrix. Using theory by theory, so we can say, let's say 4, 0, 0, 0, 4, 0, 0, 0, 4. Now, what we have in the leading diagonal 4 or true, this is scalar matrix. This is scalar matrix. So in the other one, identity matrix, we have what? 1 or true. But here we are having what? 4 different respective number you are using, apart from what? Apart from 1. That is what we call scalar matrix. Then we also have a diagonal matrix. In the diagonal matrix, we can have different number in the leading diagonal and 0 x squared. So 0 can appear x squared. So in the diagonal matrix, it's not compulsory all the numbers to be equal. Hope you get that now. But what we have in the other element is what is 0. It's not compulsory all the numbers should be equal in the leading diagonal. Take for instance, matrix A equals to 2, 0, 0, 5. Now, what kind of matrix is this? 2 by 2. This is a diagonal matrix. The elements are not what? Are not the same. So that's that. We can also use 3 by 3. Let's say 2, 0, 0, 0, 4, 0, 0, 0, 1. What we have in the leading diagonal? 2, 4. So different by 3 by 3 matrix, 3 by 3 matrix, 3 by 3 matrix. So then finally we have the triangular matrix, the triangular matrix, the triangular matrix. In this form of matrix, what we have in the leading diagonal are numbers, but your element 0 will be below or above the element that you have in the leading diagonal. This is what I'm trying to enunciate here. Take for instance, matrix A equals to, let's say, 2, 1, 3. Then you have 0. So this is the leading diagonal. If you try to bring this together, it forms a right angle triangle. In this kind of matrix, we call it upper triangular matrix. Upper triangular matrix. So the element that I have here is 0 is below what we have in the leading diagonal. We can, let me extend this further. Let's say 2, 3, 4, 0, 1, 3, 0, 0, 5. This is upper. What you have in the leading diagonal, they are numbers. So it forms an upper triangular matrix. Upper triangular matrix. We can also have lower. Let's say C matrix C equals to, let's say, 1, 2, 0, 3, 4, let's see, 1, 0, we have beyond true. Triangle. So this is lower triangular matrix. Lower triangular matrix. Alright, so that's using structure of matrix. Then finally, that's where we have different things that we need to consider idempotent matrix. 2, we have orthogonal matrix. 3, we have symmetric matrix. 4, we have skew symmetric matrix. Then 5, we have inverse of the matrix. So we need to explain all this